The ADALEM 1000 module allows students to better understand the real analog world around them, and is applicable for all students at all levels from all backgrounds. Early hands-on learning with the ADALEM 1000 will help students develop a solid science, technology, and engineering foundation.
This project focuses on operating principles of common base and cascode amplifiers and to understand how to set up the proper bias conditions for a cascode amplifier and verify that the bias voltages in the circuit are close to their design values. This is the schematic diagram of an NPN transistor of a common base and cascode amplifier. First, we can see that there are two transistors located in the diagram. The first one is a common emitter amplifier, and connected to it was a common base amplifier. In here, channel A will be the input signal while channel B is the output signal. Starting with the DC analysis, capacitors are treated as opened and it will look like this. Moving on with the common emitter circuit, we can see that R2 and R3 are in series, and if we connect it with R1, it will form a voltage divider bias. So, as the 5 volts VCC enters the circuit, the base voltage will be at 1.36 volts as shown in the figure. After that, we can also get the other two terminal voltages, which are 0.79 volts and 1.89 volts for the emitter and collector voltage respectively.
We can say that the values are valid because in a BJT transistor, the terminal voltages B and C must be in reverse bias, while voltages B and E must be in forward bias for it to work. Comparing it with the measured values, it shows that the transistors are working properly. We can see that the collector voltage here is equal to the emitter voltage of the common base amplifier. Thus, the current flowing from the collector to the emitter in the common base is equal to the current flowing from the collector to the emitter of the common emitter circuit. The base voltage is only the input voltage, but including the impedance dealt by the capacitor, it produces a value of 2.39 volts. To further prove that the BJT will work, we can see that the terminal voltages of B and C are in reverse bias, while the terminal voltages of B and E are in forward bias. In AC analysis, capacitors will be shorted while the supply will be connected to the ground. We can see that in the emitter part of the common emitter stage, the two 100 ohms resistors were bypassed because we need to obtain a high value of voltage gain in the output side. But if we want to have a maximum voltage gain of this circuit, we need to bypass the capacitor above the 247 ohms resistor. A pixel pulse application must be downloaded into any PC device since this application will prove and show that the voltage was amplified. The input voltage in channel A must be set with only around 0.2 volts to make the peak-to-peak voltages from 2.4 to 2.6 volts. and also the frequency must be adjusted to 100 Hz. From this, we can see that a 0.2 voltage input produced a value of 2.1 voltage in the output side.